This is my Genius Hour project for the Mindset, Motivation, and Self-Directed Learning course through Winona State University, taught by Professor Jen Hegna. And I am Andy Petton. The project focused on a course that I'm working on called Grand Challenge Design, and some real quick background on Grand Challenge Design. The idea is that it's where big world issues such as healthcare problems or global security or looking at all the different environmental challenges we face, energy, and a lot of other things that come from that, how do those problems affect our world? How are they interconnected to each other? And what is it that we can start to do about them? And when we say meeting innovative solutions with these big problems, the specific focus area we're looking at is the Internet of Things, this concept that everyday devices that we use now are going to be able to have lots of intelligent sensors that feed data back into the overall internet. These devices will be connected to the web, and that information will be able to be used intelligently, and servers will be passing this data around, processing this data, and doing useful things with it. We look at a very simple level right now with things like the little strips on the highway that measure how fast cars are going over it, and that data getting fed back into something like Google Maps, which will automatically route you along the most efficient routes without any human intervention. Looking a little bit more into some of those big problems, there's something called the National Academy of Engineering's Grand Challenges. And what they did is they posed 14 big problems that give some specific focus for the future, that if engineers and interdisciplinary teams can tackle some of these issues, is going to make life that much better in the future. So things like making solar energy economical, or reverse engineering the brain, or improving virtual reality, advancing personalized learning, improving health informatics, improving urban infrastructure, providing access to clean water. Things like that are the kinds of issues that we're going to be focusing on in this class and discussing and working through. The technology areas on the solution side, on the innovative approaches to the Internet of Things, we're going to have physical devices. So for that, we're going to use CAD modeling software like Autodesk Fusion, along with 3D printers that can produce these, and 3D routers, or 2D routers that will cut out shapes from, let's say, a piece of plastic or a piece of wood. On the digital side, we're going to use Node.js, which is a framework and language that allows you to write code on a server. And we're going to also be using the electronics based on the Arduino and the Raspberry Pi, which are low-cost microcontrollers and microcomputers that allow us to build circuits that have these different sensors feeding this data back onto the internet to our servers, where we've written the code to do something with it. Now, getting back to the course in this Genius Hour project, initially this course was going to be very practical and very hands-on, and I was very excited about teaching it. Students were already signed up. But this Genius Hour project offered the time and creative push to make it the awesomest class ever, which is my new goal. Now, obviously there's going to be a lot of kinks in this process, but I think the vision of where we're trying to go is going to be really cool. And the main thing that's changing from what I already described to where this class is now going is that we're trying to make it a game. And so you can imagine looking at something like this and say, oh, SimCity 2000, I remember that. I played that. I was really into that. It's an immersive simulation of the world. And you need to have your residents stay happy. You need to make sure that you produce your industry, but also places for people to live. You have transportation, things like that. It's a fully digital game, but still can be very immersive. and this is Civ 5. There's lots of different versions of the Civilization games over time, but the idea is that you're building up a civilization and you interact with neighbors and you mine resources and you're running through a simulation of how the world works. Now, if you can imagine having students get dropped into that kind of simulation, into that kind of game for the entire school year, we go from this slide here, big problems meet innovative solutions, to big problems require innovative solutions for things like the Internet of Things. The reason why this mind shift matters is because before, these big problems were going to be kind of secondary discussion topics that just get slapped on top of an electronics class, and fundamentally nothing would really change from a lot of traditional education. Here the idea is that the problems are really the focus, and they're going to motivate us to look for solutions, and the Internet of Things types of technologies are the solutions themselves. So now this world goes from just being this game world to something the students are immersing themselves into. A few reasons why I think immersive games are far more motivating, useful, and awesome than tutorials and working with real-world clients is, for one, your problems always come first. That's what we're talking about with the situation motivates you on what to do, and the solutions that you design using different technology has to fit the problem. It has to actually solve a specific problem, and you'll know you're done when you found a way to solve that, and ideally the simplest way to solve that. One thing that people really don't think about when designing real-world projects is that real clients delay the workflow or the learning process in a lot of cases. I might be working on a project with some organization or some customer, something like that, and all of a sudden they're on a business trip, they're not available, or something came up at their office and they can't meet this week or next week, and suddenly a lot of projects get really stalled. Now, there's lots of teaching techniques that you can come up with to have multiple projects going on or have students shift into other types of work, but it is a huge challenge in any truly project-based class that's working with real customers, real clients. So if there's an alternative to that that can still achieve a lot of the same learning goals, it can be actually beneficial to not work with real clients. Third one here, hard constraints make the iterative design process necessary. What I mean by that is a game has very specific rules, and you don't have infinite resources or money available to you at all times. So if you're partway through this game and you only have this much money to spend, but your people are going to starve next turn, causing a whole host of problems, you're going to need to find some way to just get something that works. It's not going to work well, it's not going to be beautiful, it's just going to function. And later in the game you might upgrade that or change that or completely replace it based on what your needs are at that later time. Or you might find that that hack solution actually works really well and you are able to continue to use it and even replicate it. Fourth one, cooperation isn't forced but heavily nudged. One of the things about this game is it's not going to require anyone to work together on specifically set teams. However, if, for example, you have a population of people who are not eating enough and are starting to get sick, and now all of a sudden diseases are breaking out, those diseases might spread to neighboring territories. And as a result, neighbors are encouraged for their own sake, selfishly, to make your people healthy, to somehow help you and work with you to do that. And there's lots of cooperative mechanisms built into the rules of the game. And then finally, engagement and buy-in should be way higher with this immersive game experience versus just assigning students to work on some tutorials for a while and then assigning them clients that they can work with. This is an untested theory, but based on the way I've seen students immerse themselves in all kinds of different games, I think that this is going to be the case. A little bit more about the game specifically. The physical game board is going to be about 5 or 6 feet by 15 feet large. It's a huge wooden table that we're going to be building, and each of those little holes that you can see up there represents, you can imagine a plastic solo cup sitting in each of those, and for many of the plots they're going to be filled with dirt, and you'll actually be growing plants. You'll be running a real agricultural business, a farm, within that little potted plant, that little plot. And you'll be having places for all kinds of different things, such as you'll need to build cities or towns to house your people. So you're going to be covering some of these game spots here with buildings that you make. You'll need power plants. You'll need a way to get electricity around, so you'll need to build power plants, and you'll need to route wires around the board so everything can be powered. And you also have a lot of signal wires that need to be routed. You'll have factories. You'll need to be able to make goods. You'll need to be able to mine raw materials from the map and then reprocess that. And these are things that are going to physically happen. It's not just build a little model and say it's going to happen. Your factory will actually need to take little chunks of clay and stamp it into some kind of shape. Your cities will need to light up and follow certain patterns to show that people are there. It will actually need to have water come to it, physically real water, and it will get polluted and become dirty and then need to be sent out somewhere. Your crops, you will actually grow plants. You'll weigh them, see how much they weigh, and based on that, that's how much your people will eat. You will not actually build a nuclear plant on the map, but certain things like that will be more simulated. Some industry students could end up going into. They could help with transactions and facilitate an easier way to exchange between players and kind of go into the banking industry. They could build widgets. They could get involved in shipping, building roads or railroads, and physically transporting devices on little rail cars that they build. They could build ships. There will be water on the map. That middle section back here will actually have literal ponds sitting in it, and that will flow between each other to keep track of water in the game. And you can ship things over those water lines. There will be a need to distribute power, as I mentioned earlier. Someone could get involved in pumping clean water into cities and into farms to irrigate the farms so they're more cost effective. Somebody could get into farming and buy up a whole bunch of farming plots, not just subsistence, but actually outsourcing or shipping out some of these resources. Someone could also just be a contractor, a government contractor. I'll throw out projects throughout the year of things that I need built for the sake of everybody, and they could choose to earn money, virtual money in the game, to run their economy and support their people by knocking out these challenge projects that I put out. Some of the problems that they're going to have to deal with along the way are going to include the fact that when they build a factory, the pollution might mess up the water, and now you have polluted water, and that polluted water might make people sick. It might hurt your farming operations, and now people are starving. There are all kinds of interconnected, interrelated problems where doing one thing that helps you might do something else that hurts you, and so you're constantly having to evolve and make the system work. One of the big challenges for me is that this is really hard. Designing a simulation of the world turns out to be incredibly challenging. Thankfully, I have an incredible support network of people who have been working with me and helping me think through this and giving me comments and feedback throughout, and just sitting down with me for hours to talk through all of these challenges. So for all of those people, I'm incredibly grateful. But it's still really hard. So hopefully I can continue to fail forward in this process, and as I look at my next steps, first thing I'm going to do is bring students fully on board this week with the design of the game and giving me feedback. I want to make sure that this is something they fully buy into and make some serious changes right now while I have a month before school starts. Next thing is take a deep breath, because this is very mind-blowing and difficult and can be a little stressful at times. I just need to step back a little bit and continue to work to design this as best I can. And I need to, in that process, calmly model myself moving forward through uncertainty in an iterative process. I am working one step at a time, and as I do one thing, I find that it causes problems somewhere else, I'll address that problem next. I take one thing at a time, get it in writing so that I can move forward and test the next step. And of course, step 4, win. Just, that's the goal here. So I'm very excited about the new course taking this different direction. I'm excited that this class has given me kind of a conduit or reason to try something a little bit crazy. And I'm excited to see where things will go and keep you updated. Thanks for listening.